So lesson P6 is complex numbers. Dig deep. We learned in Algebra 2 about complex numbers for the first time. Okay. If you kind of start scrolling the notes, you'll see something in here. What's a complex number involve? Imaginary numbers. So Algebra 2 is where we first introduce the imaginary unit. I is what represents it. That's what a complex number is. So a complex number is anything that is in the form. Do you remember the form of a complex number? A plus BI. So when we talk about complex numbers, we're talking about the form A plus BI. Now, okay, we've talked about I. What is I? Besides a letter of the alphabet. What is I when we're talking about the imaginary unit? No? It's an imaginary number, but what is the value of that imaginary number?
Whatever you imagine it to be.
No. There's a specific value because
just itself. I is equal to itself.
Isn't it like square root of I?
It was like negative.
put those two together, guys.
The negative square root.
She's saying something to do with a negative. He's saying something to do with the square root.
The negative
Square root. So officially, I is the square root of -1. Because until we talk about imaginary values, when we go take a square root of a negative number, we always just say you can't do it. And the idea is when you go take a square root of a negative number, it's not a real number. Prior to Algebra 2, prior to learning about I, we just said you can't do the square root of a negative number. Well, now, when we're using imaginary numbers, you can take the square root of a negative number because I is represented as the square root of -1. We definitely did not remember that very well from last year. Now, the other piece of information to remember, if I is the square root of -1, what is I squared? Not 1. -1.
Yeah.
Because when you square a square root, so when you square the square root of -1, the square root cancels and you're going to get -1, right? Okay, so there's the kind of preliminary information. Now, basically we're going to do a little bit of everything with i's today. We're going to start by adding and subtracting complex numbers, which, as you look at these adding and subtracting complex numbers, basically it's adding and subtracting as if I is a variable, combining like terms. So when I have 7 minus 3i plus 4 plus 5i, what happens? What kind of answer do I get when I add those? Half, right? I think.
Oh no.
No. So she said 3 minus 2i, and I said she was half right.
Oh,
Oh, actually, there's
11
11
minus 2i.
and there's still a small mistake I just caught. Now we're at 11 minus 2i. 11 plus 2i.
Yeah.
What?
So, what do you do?
Okay, so
But that's a negative.
okay.
Gosh.
So please note, this is an addition problem. Okay, which is where we were having issues. Okay, so this is an addition problem. We're going to add like terms. 7 plus 4 are constants like terms. 7 plus 4 is 11. And then we have negative 3i plus positive 5i. Negative 3i plus 5i is 2i. Can I add 11 and 2i? No, they're not like terms. And right there, leave answers in the form a plus bi. That's what you're going to hear me say all throughout today. So 11 plus 2i. Okay. We got all of our silly mistakes out of our system now, right? This is taking a bit, guys. I'm really having to drag this out of you this morning. Okay, let's try B. We're going to take 2 minus I minus 8 plus 3i.
I think I do too, but I don't want to say it because I did it wrong.
Someone's got to get us started, so we have a starting point.
-6 minus 4i.
4?
That's what I got.
Oh my god.
Yeah.
Sophie!
I see what I meant. Okay.
Okay, so the key to point out here, first of all, note, this time it is subtraction, yes?
Yeah.
So when we go to do our like terms, one part we're doing is 2 minus 8. I don't like that 8. And 2 minus 8 is -6. The next part we're doing is -I minus 3i. And so we do -I minus 3i, that's -1 minus 3, and so that is -4i. Okay, you're getting all these mistakes out of your system now, right?
Let's hope so.
It's just one of those days.
Okay. Example 2. We added, we subtracted. Now we need to multiply. So adding and subtracting, there was a plus or minus sign in between the parentheses. We were adding and subtracting like terms. Multiplying, it's parentheses times parentheses. The trick is foiling. So if we FOIL this first, or another word for FOIL,
First.
distribute. What if I use the word distribute, girls?
That'll work.
FOIL is, but it's probably an American thing, but it's just an acronym saying FOIL is we multiply the first terms, O being outside terms, I being inside terms, L being last terms. But it's a fancy way of saying distribute. So first, we're going to distribute the 2 to the 5. And 2 times 5 is 10. Then we're going to multiply the outsides. So we're distributing 2 to -I. 2 times -I is -2i. I being insides. So we're distributing 3i to 5. 3i times 5 is 15i.
Okay, I think I did this one.
And then L being last. We're distributing 3i to -I. 3i times -I is -3i squared. Does that help explain what I mean when I say FOIL back there? Okay. We use the acronym FOIL, however, it's an acronym. Distribute is what we're really doing. Okay. Am I done? No? What do you see here?
3 -3i squared.
Ah, you see a -3i squared? What about that -3i squared?
-3 times
Yeah. Remember, I squared. So if I do a little side note here, -3i squared, it's -3 times I squared. Remember we talked about I squared is -1?
Yeah.
So -3 times -1 is +3. So that piece is going to become a +3. And so I heard something about like terms.
Yeah.
What are we putting together then?
You'll do 10 and +3 and -2i plus
13.
So 10 plus 3 is 13. And
I'd say that
-2i plus 15i is
+13.
+13i.
Did you get one?
I got one. I got it right.
Okay. At this point, again, we don't have like terms, so we're going to stop here. Okay. We're getting the basics here. Yes, make sure we stay focused because we are very chatty today. There's good and bad to that. Use the chatty for the good, right?
We're halfway there.
Okay, example 3. Raising a complex number to a power. So, we're told z is this lovely complex number 1/2 plus square root of 3 over 2 times I. And we're being asked to find two things. We're being asked to find z squared, and we're being asked to find z cubed. Now, in order to find z squared, that is the idea of taking z, which is 1/2 plus square root of 3 over 2 times I, and squaring it. If I write a number like that has two terms, and we're going to square it, what do I really have to do? When we square that, I'll write this out here, we actually end up doing this binomial times itself. Okay, so it's parentheses squared, and you can go ahead and write that, but we end up doing parentheses times parentheses. And I write this out in this form because the visual will help us be able to distribute, FOIL, if you will. And we just have to fight the fractions. Okay, it's doable. Step by step, right? So first, 1/2 times 1/2. 1/4. Then it's 1/2 times square root of 3 over 2I. So 1 times square root of 3 on top is going to be square root of 3. 2 times 2 on bottom is going to be 4. And then times I. So square root of 3 over 4I.
Yes.
Okay. Now we're going to multiply the insides. Square root of 3 over 2I times 1/2. Well, same thing, right? 1 times square root of 3 over 2 times 2 times I. And last, square root of 3 over 2I times square root of 3 over 2I. Square root of 3 times square root of 3. 3. 2 times 2, 4. I times I. I'm going to write I squared for the moment. But yes, we're not going to leave it as I squared, right? When we're working with imaginary numbers, I should never see I squared in your answer. Okay, ever. Okay. And I'm going to, so we don't forget, this is Z squared that we're doing here. I think I usually put 2 more lines of work in. We'll see if we can get this dealt with here. Okay, at this moment, 1/4 is just 1/4, right? Nothing else to do with that yet. Now, when we talk about square root of 3 over 4I plus square root of 3 over 4I, hopefully, can you at least identify those as like terms? You may not know how to add them, but they're like terms, yes? They both have the radical 3, so they're like terms in terms of radicals. They both have an I, so they're like terms in radicals. What I'm going to suggest is you envision a 1 in front of each of those. So what I want you to think is that we're adding 1/4 square root of 3I plus 1/4 square root of 3I. So because when we add radicals, we add the coefficients in front. What is 1/4 plus 1/4? Okay, becomes 1/2 eventually, yes? Because I still have another line of work for the moment, 1/4 plus 1/4, I'm going to write it as 2/4. So it's going to be 2 radical 3 over 4I. Can you get with that? And again, I'm going to clean it up. I am going to put 1/2 in my final answer. I'm just not to my final answer yet. What about this 3/4 I squared?
You'll have to replace the I squared with
Negative
Yeah. I squared, if you recall, is -1. And since that's -1, 3/4 times -1 really becomes -3/4, right? Okay. Clean up. Final answer. 1/4 can go with -3/4. 1/4 minus 3/4 is
Negative 1/2.
-2/4. But then since we're at final answer, we're going to go and say -2/4 is -1/2. And then 2 radical 3 over 4i. There's nothing else to add it with. I didn't reduce 2 fourths last time. I'm going to now. 2 fourths reduces to 1/2. The 1 on top in front of the radical, I don't have to put there. The 4 on bottom becomes a 2. So I can say plus radical 3 over 2 times I. Okay. And you could still have it if you want that visual of 1/2. You could still have the 1 out in front of the radical and say 1 radical 3 over 2 times I. You could also bring out, you'll sometimes see that written as 1/2 radical 3, where the radical 3 is more like with the variable. So that's equivalent as well. Okay? That was a little bit of work, wasn't it? Okay, it's doable though. You have to be very careful. Watch out for those careless little mistakes. Whoops. Now,
Slowly.
exactly, slowly, right? Now I will say, I know when I taught complex numbers last year, I don't think we ever did it quite this much. Not with all the fractions and radicals mixed in.
We did something like that, but it was never fractions.
Yeah, not with the fractions and radicals all at once. So, now, am I done with this problem?
No. See the
No. They want us to find z to the third. Now, be smart. Okay, so z to the third officially means we're going to do z times z times z. However, what would be smart if we write here?
Just take the answer to the square root of the square.
Yeah. What I would think of doing is, let's actually think z squared times z. That would be my thought. You know, assuming you didn't make any mistakes on z squared, this will work out perfectly fine. So, z squared, I'm claiming, is negative 1/2 plus square root of 3 over 2i times z, which we were told was 1/2 plus square root of 3 over 2i. Ready? Okay. Again, we're doing the distributing, right? Negative 1/2 times positive 1/2. Negative 1/4. Negative 1/2 times square root of 3 over 2i. So a negative times a positive is going to be a negative. 1 times square root of 3 is going to be square root of 3. 2 times 2 is going to be 4 times I. Then my middles. Square root of 3 over 2i times 1/2. Square root of 3 times 1, we're going to have positive square root of 3. 2 times 2 is 4, and then times I. And lastly, multiply your last. Square root of 3 over 2i times square root of 3 over 2i. So square root of 3 times square root of 3 is 3. 2 times 2, 4. I times I squared. What can you recognize here? What?
What's the word when the middle terms cancel?
Okay, very similar to last time. Middle terms are going to cancel here. What it means when the middle terms cancel is we multiplied, these are conjugates up here, if that's the word you're looking for. Okay, and we're going to need that word right there, down in the division section. But conjugate meaning, normally when we think conjugate, we think about changing the middle sign. But really a conjugate as long as one of the two signs is different. And that's exactly what happened here. So negative 3/4 square root of I plus positive square root of 3 over 4i are going to cancel. We know I squared here is going to become negative 1. And so we ended up doing negative 1/4 Instead of plus 3/4 I squared, we're going to say minus 3/4. What is negative 1/4 minus 3/4? Negative 4/4, which is negative 1. Now, I get it. I'm happy with negative 1 as an answer. Officially, a lot of your homework is going to say leave answers in complex number form a plus bi. How could I write negative 1 in the form a plus bi? What was it? So the answer negative 1 is always, every day of your life, is equivalent to saying negative 1 plus 0i. Saying the real component is negative 1, the imaginary component is 0. We just don't on a normal base talk about the imaginary component being 0 and always being there. Okay. Doable, yes? Maybe not as fun as part 1 and 2, but doable. Okay. Okay, moving along to example 4 then. We've added and subtracted. We've multiplied. We've done powers, so we've done extensive multiplication. Now we need to divide. Now, dividing. Remember, dividing is also a fraction form, yes? And so that's what they're set up here. I mean, you could try and do like a long division thing, but it's not going to really go anywhere for you. And so one of the big things, if you remember fractions, do I want to say it's illegal? I should say it's illegal. It's not proper form to leave a square root in the denominator, right? And I is technically a square root. So it's not proper to leave an I in the denominator. So in order to do that, we want to get the I out of the bottom, just like we want to get a square root out of the bottom. So essentially we are rationalizing this fraction. If you remember rationalizing, your goal is to get the square root out of the bottom. And so we just talked about this word. We're going to multiply by the conjugate. The conjugate of 3 minus I is typically considered to be 3 plus I. What you do to the denominator, you do to the numerator. So we're going to be multiplying numerator and denominator by 3 plus I. And then it just turns into multiplying and cleaning it up. On top, how do we multiply 2 times 3 plus I? Yep, basic distribute. So 2 times 3 is 6, plus 2 times I is 2i. On bottom. Distribute both pieces, or FOIL if you prefer. 3 times 3 is 9. I'm going to do the whole thing here. 3 times I is 3i. Negative I times 3 is minus 3i. Minus I times positive I, minus I squared. What can you tell me here? Okay. Okay. On bottom, we just multiplied by the conjugate. If your middle terms don't cancel on the bottom, you've made a mistake. Okay? My 3i should be canceling. And then minus I squared is really going to be minus negative 1, right? Because I squared is negative 1, so we're really saying minus negative 1, if you will. So when we clean this up, on top we still have 6 plus 2i. On bottom, what do we have? 10, because it's 9 minus negative 1, so 9 plus 1, which is 10. Simplest form always. This is not simplest form. Very close, but no. What do we need to do here? We need to reduce. How can we reduce?
3 over 5 is fine.
Yeah. All three terms. Now, in order to simplify this, every term has to be divisible by the same piece. And 6, 2, and 10 are all divisible by 2. So 6 divided by 2 is 3. 2i divided by 2 is I. 10 divided by 2, 5. Now, you won't see the answer in the answer key quite like this. Okay, they're going to, I'm running into the next problem. They're going to go one step further and say, okay, if we want it in the complex form of a plus bi, right now it's a plus bi all is one fraction. So if we separate this out and make it a real part a plus a imaginary part bi, we can break this into 3/5 plus, did I write it as 1/5 I? Or I over 5. Okay, so I actually wrote it as I over 5 here. What more traditionally you see is 1/5 I. Okay, that ideally would be the answer I'd be looking for. So division isn't really just division in this situation. It's not really division at all, is it? It's multiplication. Okay, let's try one more. 5 plus I over 2 minus 3i. What do we need to do? Sorry, I just realized I didn't stir this earlier. I want to make sure I'm not burning the pot.
What is it?
Chicken dip. Sorry, I know I shouldn't do this during the middle of class, but
I think we should have a sample.
Yeah. Like a Sam's Club?
sorry, it's not Sam's Club. No samples right now.
Is it for like teacher? Like
We have to pitch in today. Yeah, we have a pitch in today, and if I put it down in the teacher's lounge, it won't necessarily get stirred, and here I can make sure it gets stirred, and hopefully make sure it doesn't burn.
I love the little baby crock pot.
Yeah.
It's so cute.
But it's a perfect size for the chicken dip I do.
My mom has like 5 to 10 crock pots.
Guess ours is
everywhere.
That's perfect.
Okay, guys, back to pre-calc. 5 plus I over 2 minus 3i. Did you start it?
Yeah.
What did you do?
Nothing. Well distributed. I'm honest.
We are going to multiply by
It's perfect how it is.
2 plus 3i, yes?
Yes.
Because we're multiplying by the conjugate of the denominator. If we multiply the bottom, we're going to multiply the top. Okay. Only big difference in this one is we are foiling top and bottom. So, on top, 5 times 2, 10. 5 times 3i, 15i. I times 2, 2i. I times 3i, 3i squared. On bottom, 2 times 2, 4. 2 times 3i, plus 6i. Minus 3i times 2, minus 6i, minus 3i times plus 3i, minus 9i squared. Okay. Important pieces that happen. Did the conjugate do its job? Yeah, the conjugate does its job if the middle terms cancel. So that's going to happen. These I squareds are going to be -1s, yes? So, when we do some cleanup here, on top, what happens?
17.
Yeah. This, when we say plus 3i squared, it really becomes minus 3, doesn't it? So 10 minus 3 is 7. 15i and 2i is 17i. On bottom, minus 9i squared really becomes
Plus 9.
plus 9. 4 plus 9 is 13. To officially write this in complex number form, I'm going to say 7/13 plus 17/13 I. Okay, we're getting there. We keep moving quickly. I should be able to finish the notes. We've done the hardest of it, if you ask me. The raising the powers and dividing the complex numbers, I think examples 3 and 4 are the hardest parts today. Now, some of you are going to argue quadratic equation is the hardest part because you don't like quadratic formula, but I don't think it's the hardest part here. So, solving this quadratic equation, here's the deal, guys. If we're in the imaginary numbers, we're not going to be able to factor this, okay, because we're going to have imaginary roots. So, if it doesn't factor, final plan is quadratic formula. I saw pink paper come out. This is one of the things that was on the pink paper, wasn't it? That I said we haven't used yet, but we're going to. Although we used quadratic formula in the last lesson too, didn't we?
Yeah.
So if you've forgotten your quadratic formula, it is there. There's a song you can always go sing, right? Okay. Before we can use quadratic formula, we have to make sure the equation is equal to 0.
It is.
What is A?
1.
What is B?
1.
What's C?
1.
Interesting. Not often you have that happen, right? So, x is equal to negative b, so negative 1, plus or minus the square root, b squared, so 1 squared, minus 4, times a, which is 1, times c, which is 1, over 2 times a, so 2 times 1. On top, negative 1 is still negative 1, plus or minus. What happens under that radical?
It's 1 minus 4, isn't it?
Okay, 1 squared is 1. 4 times 1 times 1 is 4. And 1 minus 4 is negative 3. All over denominator of 2. Now, back in algebra, if we were just working with real numbers, we would stop here and say, no solutions, indicating there are no real solutions to this problem. However, there are going to be 2 imaginary solutions. And that's what we're in the process of finding. So in lesson P6, your number under the radical should come out negative because we're looking for our imaginary roots today. Okay? So, how can I rewrite that square root of negative 3? Because I want to use an I instead. I want an I involved. What's your guess?
3i. No. Just
Okay, so here's what I'm going to have you think. Think under your radical as negative 3 being equivalent to negative 1 times positive 3.
5 times the square root.
The square root of negative 1 can become I. The square root of 3, I can't take that square root, so it just stays square root of 3. Now, what if this had been the square root of negative 9? Then I would say 3i because I could actually take that square root. Okay? So I'm going to say negative 1 plus or minus I times the square root of 3 all over 2. Traditionally, we put our i's out front of radicals just so we can clarify that the I is not under the radical, just like we often do with variables. If I'm going to write this as complex form, so it's real part plus or minus imaginary part, negative 1/2 plus or minus, and you can write this one of 2 ways. I'm going to say I square root of 3 over 2. However, you're not wrong if you say square root of 3 over 2 times I like that. Okay? Doable? As I said, to me, that's easier than all the foiling stuff we were doing up there, but I'm not against quadratic formula. Some of you I know love it, some of you don't love it. So,
It's the only that makes sense. Awesome.
okay, example 6. I don't remember if we did this last year or not, but plotting complex numbers. Okay, when we go to plot a ordered pair, we usually have an x-axis and a y-axis. Except we don't have an x-axis and a y-axis when we're plotting complex numbers. We have a real axis, which is represented by A, and we have an imaginary axis, which is represented by B. So you have an A-axis and a B-axis, essentially. So, for example, if we want to plot U, and U is 1 plus 3i, what ordered pair will represent 1 plus 3i? Yeah. So for U, we're going to plot 1, 3. How do we plot 1, 3? Right 1, up 3. I know, this is hard. It's tough stuff there, right? Okay, V is 2 minus I. Thoughts on the ordered pair for 2 minus I? Yeah, there's an invisible 1 there, and it's negative. So 2 negative 1, which means I'm going to go right 2 down 1, and that's going to be V. Now, it also asks us to plot U plus V. What do I need to do before I plot U plus V? Should we maybe find what U plus V is?
Yeah.
So U is 1 plus 3i plus V is 2 minus I. So when we add like terms there, what do we get? 3 plus 2i? And what is as an ordered pair? 3 comma 2. So I'm going to go right 3, up 2, and there is U plus V. Okay. I didn't think I'd get through the notes. I didn't think I did for some reason in past years.
I'm just not ready.
I don't know. Okay. Your homework,
I'm just such a big class.
which is due tomorrow, is page 52. It is all evens, okay? I wrote evens at the bottom, but everything is evens. So it's 2 through 16, evens. 26, 28, 34 to 38, evens. 42, 44. And that is all evens. Okay? Now, work through it. There's going to be some questions we need to talk about tomorrow. Okay? There definitely will be. Work through it. Come back with questions tomorrow.
I thought it was a game with me.